No cuts, baby.
It's very satisfying to watch.
Yeah.
Especially this section towards the end where the scenes flash, and if you pay attention to the actor's face, you notice how the lighting just works.
Right.
Very cool. Yeah, Richard in the chat here.
Hello, everybody. Good morning. I'm Dr. Sacha Malik, CEO of OpenCV. Recently, we have seen computer vision being applied to live performances and productions in never before seen ways, and it is an exciting time for the industry. Our guest for today's episode is George Profenza, a former OpenCV AI competition participant and computer vision engineer specializing in projection mapping and mixed reality. Today, he'll be showing us a new method of real-time markerless motion capture called Invisible. But first, with me, as always, is Phil Nelson, the Director of Content and Creative at OpenCV. Phil produces the show, and so if anything goes wrong, it is his fault.
That's absolutely right. Before we get started today, I would like to wish a happy trails to the one and only superstar, Billy Graham, the man of the hour, the man with the power too sweet to be sour, more jiggle than a bowl full of jello. And let me tell you something, Daddy Jello has a lot of jiggle. I am your co-host with the co-most, the second banana who is second to none. It's Mr. Nelson, if you're nasty, but you, I think by now you know you can call me Phil. And I'm here to remind you of a few things we do every single week here on OpenCV Weekly, the first of which is a special giveaway to you in the audience. Later on in the episode, I'll be asking a trivia question here in the Zoom chat, which you can get to by going to opencv.live. And then you'll be able to win the OpenCV course of your choosing. One lucky winner later on in the episode. Stay tuned for that. We're also taking questions from you in the audience, and we will do our best to answer them during the show. Ask your question anywhere you're watching, whether it's on Twitch, LinkedIn Live, YouTube, whatever. We'll do our best to flow it into conversation. We're also going to try to save some time at the end of the show to answer those questions. If you're on Zoom, you can just use the little Q&A button at the bottom of the screen. That's it for me for now. Satya?
Thank you, Phil. And welcome, George. It is a pleasure to have you on the show. And please start with a short introduction. I'm really excited to see what you have to present. We just went over the slides really quickly, but I'm very excited to see what's coming.
Yeah, it's lots of fun. It's a privilege as well. Also having been one of your students with the OpenCV courses as well. So fun stuff.
Thank you.
I'm George, and today I'm going to be talking about Disguise, the company I work for, and our designer software. I'll be covering our Omnical projection mapping solution and a render stream. And moving on to XR and virtual production. This all ties in with the MoveAI integration for markerless motion capture. And we'll wrap up the show with Q&A. More than happy to answer things as we go along. So Disguise, pretty fun company to work with. And yeah, it's definitely a leader in terms of the media server company. So we produce hardware and software that powers shows and large productions, whether they're live for concerts, whether they're virtual productions for music videos, films, feature films, all sorts of crazy events, corporate events, and so on. So maybe it's best to let's go over a showreel of some of the projects the company does, which will probably paint a clearer picture than what I can do in words. But yeah, essentially, as mentioned, live events, and its beginnings were in heyday. I believe the first iteration of the software was used for the Massive Attack Tour way back when, more than a decade ago. We use all sorts of projection mapping for large scale productions. And
yeah, we were going through the slides before the show, and I said, I think large scale is very slightly underselling some of the size of these installations. Holy cow.
So one of my business partners, Dr. Matt Flagg, he's into projection mapping as well. He would love this episode. So it's one of those things that you can make such spectacular things with projection mapping these days. It's unbelievable. And I'm pretty certain that, these live performances would be nerve-wracking for you because nothing should go wrong, right? It has to be perfect. What do you think?
Yeah, absolutely right. And there's so much fun setting this up, but obviously a lot of risks. So I'll cover more about projection mapping in a few slides.
Yep.
But yeah, I can totally also feel the pain of the difference between setting up some perfect mesh in 3D world and everything virtually is just the way it's meant to, and then the real world happens and things are not quite the way they seem. But that's why you work on robust solutions to try and mitigate the risks and then deliver the best show you can with what time and resources you have available. So
Right.
this is where our software helps a lot. So yeah, I mean, I'm in a lucky position right now because I'm this one guy showcasing all this wonderful works, but I'm just one tiny little cog in the software team, and it's all great fun. But all of this is, you know, standing on the shoulders of giants, and it's great to be able to have such a solid team backing us up from all sorts of solutions. So, for example, relevant to today's talk, there's the virtual production team, and then the location-based install solutions team as well. All very, very clever people, and it's nice to be in a space where you're definitely not the smartest in the room. So just to give you an idea of the width and breadth of some of the projects we do at Disguise, there's a handful of them. So for example, I mentioned projection mapping, large scale outdoors, the whole Burj Khalifa projection map. Indoors, there's a space called Illuminarium in Atlanta. As we're going to cover more of this in further slides. But essentially it's using 46 4K projectors seamlessly, don't see any edges, anything like that. It's just nice and smooth. Lightroom is David Hockney's exhibition space recently opened in London. David Hockney being a really, really important British painter. Actually, might tie in briefly with computer vision in the sense that he wrote a bunch of books talking about perspective and how artists use technology and used it throughout history to produce some of their artworks. The Expo 2020 and our Saul, all this interior is projection mapped as well. And the BBC Earth experience, similar to Illuminarium, indoors projection mapping just makes it seamless. So in terms of software, I mentioned we're going to cover three main topics. One is the designer software, then Omnical, and then we're going to look at virtual production for with our XR solutions. So the designer software, the simplest way I can explain it is you have a very, very powerful set of pre-visualization tools. So you bring in your 3D models, your 2D assets, your videos, your audio, and you also have a timeline to sequence things. On top of that, there's a plethora of different types of layers that you can bring in generative content as well. And once you're happy designing the show, what lights go when, where, what events trigger, what happens if you want to have smoke machines, lasers, whatever your show needs, you can sequence it and you can try it out. And once you're happy, the exact same software runs on our servers. So you can have the designer on your laptop or your personal computer to design the show, and then you copy paste that project onto the servers and it runs the exact same thing. So it's going to be pixel perfect. It's designed that way. Omnical is our projection mapping tool. So Satya, you mentioned that projection mapping can be a bit of a pain, especially when things change. So yeah, the traditional workflow might be something where you painstakingly click and drag every single vertex in a triangle to map a 3D mesh onto the real world, and the wind is blowing or something's changing, somebody moved an object and you have to start all over again. What we do is we have something different where we use structured light to sort of 3D scan the scene, if you will, and create a point cloud representation of that scene, which then gets processed into a mesh. And already that's awesome because things can change, things can move. So you just hit the rescan button and everything's up to date. And where you might have a scenario where you might have the geometry for projection mapping ready to go, like an OBJ file, like a 3D mesh of some format. But that's all, you know, blue skies type of scenario where you assume that this 3D mesh that you may give to somebody to manufacture for your big live show, use it exactly as it is and gets produced the exact same way. But the limitation of the real world either doesn't get produced the way you want to, or something happens, God forbid, in transit, or whatever the case may be. For like really, really big structure, they might like sag over time, and you might land in this situation where you don't have an alignment between what happens with your pristine 3D mesh in the virtual environment versus this mesh in the real world. So what our software does on top of having this mesh, there's a feature called Mesh Deform, which allows you to simply tweak the cage, tweak the mesh, the virtual mesh to map to the real world. So that pretty much is a fixed tool that you can run live.
How much in a live performance, right? These things can be very, very distracting if things are not aligned perfectly. Does your software, I mean, I'm thinking that there could be, wind and other things which can shake the projection system or move them out of alignment. Do you do something in real time, something actively, or is it one-time setup and then you don't touch it?
Yeah, that's a very good question. So in the majority of cases, the workflow is sort of a one-time setup.
Yeah.
But until you start gathering your scene, once you have your scene and you have your mesh, that mesh you can deform afterwards because it's less likely for that mesh to, let's say, completely split in half. If that happens for a show, then there's bigger problems than that.
Right.
But if let's assume that it's part of the performance and that splits, then you would need to somehow in your show work out a way to slide in a scan pattern. So maybe like you can work around that, basically.
Interesting. But it is done, even when the scene is live, there are instances where you need to, the live performance is going on and you're tweaking the background, the projection in a live environment. Does that happen sometimes?
Yes, sometimes. So you can make some tweaks. You can make some tweaks live. Like a good example, I don't know if I have an image here. Well, you notice like with the backgrounds, everything just is seamless. You don't notice any seams in between, and this is a lot of projectors. Yeah. And one of the features the software has is dynamic blending, dynamic projectome blending, and there's also within the software there's visualization tools that show you lux, the amount of light information per scene. So it gives you a very good indication of where things are. So if something moves and you want to avoid that sort of scene, you can like tweak that sort of tweak with the dynamic projector blending. That is something you can do. And where you can make minor adjustments to the mesh. However, to rescan the mesh, that is something that pertains more to the initial setup.
Yeah, that's great. I mean, it would be great. I don't know whether you have these slides where the photo that you showed before, if people could actually see the various projections, right, the boundaries, they would be really impressed because this looks like a seamless thing, and it looks so realistic, it's so seamless that people don't realize how close the alignment has to be for you to pull this off, right? Everything needs to line up perfectly.
Correct. Yes.
Yeah,
so this is a similar
46 cameras or 46 outputs here. Yeah. Wow.
Yeah. So you notice every single projector used in this scene visualized here with its 3D pose and where it's pointing at. And something like this, like a gradient, would easily show you when things are misaligned. And because this is just another type of layer, we also have all sorts of other like grid alignment tools that make it easy to spot the smallest imperfection.
Wow.
So this is like toggling between this view and trying some actual content. Yeah. So we're going to be moving on to RenderStream, and RenderStream is our solution to send 3D real-time engine data in both directions. I've mentioned all sorts of layers you can bring into our designer software. So you have your images and your videos and whatnot, but you can also bring real-time content. So our plugin allows you to essentially stream the render frame as soon as it comes out on the GPU. You stream it to our system from Unreal Engine or Notch or Touch Designer or Unity, and of course it's a open source SDK we have on GitHub. So if there's something we don't support right now, it definitely can be supported in the future. So this is key to our virtual production system. So I've mentioned virtual production before. I'm going to talk about it in a bit more detail. So some of you might be familiar with the big blockbuster movies, all the Marvel cinematic universe scenarios where, especially a few years ago, they would use green screens and the actors are caught in these scenes where they need to imagine exactly what is it in front of them and try to give the best performance they can with really limited resources. And in addition to that, for the whole production team, you have people working in post that need to gather that footage that's been shot on the green screen, do all the alpha matting, like cut out all the people in the foreground, look up like tiny imperfection when it comes to shadows and reflections and all of that. Alternatively, you could use an LED stage instead of a green screen. And this is what our virtual production system is composed of. So we have an LED screen here in the background, and notice the camera on top of the camera. It's kind of hard to see, but it's a real-time tracking system. And this combined with our software solution allows us to give you one perfect perspective from the point of view of the camera. So this 3D wall looks correct from the camera's view. And the advantages are huge because you can just do it all real time. So you cut out the middleman with the having to do all the rotoscoping, boring work that no one really likes to do. The director is happy because she or he, they can make the decisions, they can visualize the data live. And for the actors, much easier because they're immersed in the environment. So in terms of the technical nitty-gritty, we've got our Disguise VX server that's in charge of like talking to the cameras, the tracking system for the cameras, the LED wall, the LED controller to control the content on the LED wall. And then through render stream, we talk to a separate rendering server. So it's a whole machine whose whole job is to run your 3D engine, Unity, Unreal, whatever it may be. And that streams it back as if it's just a layer, like a Photoshop layer, if you will. It's only that it's real time.
So and people, you know, some people may not realize that when we do green screening, a lot of people assume that, oh, you just do green screening, you run, you know, matting algorithm and out comes a beautiful picture. But when you're looking at movie quality, that's never the case. People go look at each and every frame. So this is manually done, right? After green screen software has run to remove the background, they look at every frame and manually go and paint each frame if necessary, right? And that is a huge pain. People don't realize that, oh, these things, there is a lot of automation, but still there is a huge amount of manual work as well.
A lot of invisible labor there for sure. Like, and you got to remember, a lot of these, we're talking 4K or even 8K shot, 60 frames a second or higher. That's a lot of like manual labor to go through each frame, fixing weird little reflections and where the matting didn't quite work, and et cetera, et cetera. It is a massive amount of labor for sure.
Right. And also, you know, the way green screening was done, because the actors do not know where the other objects in the scene are. So when shooting of Jurassic Park, you know, they shot it using green screen. And there was a scene where the person is, the whole family is running, and they're looking behind to look at the dinosaurs, right? The way it works is because you don't know, you know, how these little kids will look at. So they put the dinosaurs after the screen is shot based on where the kid looked, right? That, oh, they looked on top of their shoulder, so they put a dinosaur right there. So it's a lot of hacks like that that need to be done in post, which is not ideal. And a lot of these things are solved when you use this kind of technology.
Yeah, exactly. Thank you so much for covering that in a lot more detail. And the day of shoot costs a lot of money when it comes to like the hiring the space and the amount of helping hands you need on the day and everything. So anywhere where we can save time and make this as easy as possible for everyone, it's definitely worth doing. So this video probably explains the virtual production, the benefits of it way better than I can. So you notice how the scene changes like live in real time. Notice the beautiful reflections on the car. And notice the actor sees exactly what's going on and can easily interact with the scene. And if you look at the actor's face and the lighting on the face and the clothing, it's all done live real time. So you don't have to worry about as much as all this painstaking work that Dr. Satya just mentioned.
Wow.
Really impressive stuff. Thank
you. Okay, so finally we get to the fun part. I mean, it's all fun from my point of view, but the reason why we wanted to talk to you today is we have a partnership with MoveAI, and what they do is they have a deep learning based solution for real-time motion capture. So what I do is, again, going back to Marvel movies and all this sort of scenario, you might have seen some behind the scenes footage where somebody's wearing some sort of a cat suit with markers on, or all sorts of like light, bright white spheres around the joints and so on and so forth. So these are examples like motion capture suits. Other alternatives include using IMUs, like inertial measurements units, which are a combination of gyroscope, magnetometer, and accelerometer, and those can give you the 3D poses, but not necessarily positions. So you can have like a hybrid motion capture sort of solution with some IMUs and some markers live. But it always takes time to set this up. And especially if you want to have people kind of moving in and out, like different actors trying different takes, different shots, it always takes time. The solution that Movie deliver can do it like live in real time, as in 60 frames a second. I can track up to 2 people. And yeah, there's so many advantages to using something like this. So traditionally, if you needed to animate something in a 3D movie, either you need really talented people to manually create the meshes, rig these meshes, and then animate them to bring them to life, or you need people wearing the complicated suits, or now there's a bunch of AI-based tools now that can help with a bit of the cleanup, but it's still cleanup in the end. So similar to the analogy with green screens and looking at every little reflection or shadow that's in the wrong place, a tool will only go as far as in terms of cleanup. It's better to get cleaner data to begin with if you can. So like garbage in, garbage out type of scenario that many developers may be familiar with. So this is an overview of what their system looks like. So they use multiple cameras, and for each camera view, they get the 2D key points. So there's 29 key points. And then once these key points are visible, then there comes the hardcore math to work out how to go from 2D to 3D. But it's not simply your typical multi-view geometry affair where you want to go from 2D to 3D and solve where those positions are, but also look at more complex tasks such as like inverse kinematics, or looking at the restrictions of the human body to try and constrain things so that the body motion is realistic. And so you're sort of balancing between something that's as close as possible to the motion, removes as much noise as possible, but still ends up being as fast as you can. So there's a very tight space for maneuvering there. And with other people that might have played with machine learning systems, again, the data you put in has a huge impact on what you get out of it. So obviously, if you train it with high quality data, looking at a wide range of motions, then that gives you better odds at your system handling much more complex, much more richer scenes. So ultimately, this helps a lot with producing high quality content, and it just simply empowers all the creatives on the team. So this is our invisible solution. On the left-hand side, we have a screenshot of like an alpha version of the software. So you can see like 6 cameras picking up 2 people at the same time. And on the right-hand side, we see a previous screenshot from our designer software. So we just get skeleton data with the positions. Already at this stage, once you get the data in the designer software, you can literally drag and drop this. Like we have like an expression system where you can map these 2 positions for, let's say, DMX light control, and you can have stage lights, for example, in a theater production following somebody on stage, or once they do a certain gesture, that gesture can trigger a different event. So because we're talking MIDI, DMX, streaming ACN, all these other well-known protocols in the creative world, it's so easy to just get data out of it and control your show live. But on top of that, we also integrate with RenderStream. So your typical setup for a solution would be something like this: 4 to 8 cameras around the space that you want to track. Like this, 4 cameras is minimum, but it sort of depends on like the scale of the space that you want to cover. So ideally, you want to make sure that you're covering the whole area, and each camera has a clear view of every single subject. And this helps a lot as well, because you might have areas where you have occlusions or like trickier shots, or somebody isn't fully visible in one camera, but then all the other cameras sort of fit into the system and helps reduce the jitter and the noise. Yeah, we got the cameras fitting into the MX Move Invisible server. It's one job. All it has to do is the motion capture data. Once it's got the data, it sends us to our designer, to a server running our designer software. So there can be a VX or GX server. And finally, if you want to display nice content on the LED wall, you can forward that data to a real-time engine like Unreal. And let's say you have a really, really complex Unreal scene. Your creative director wants you to do all this super nice post-processing effects in real time with blurs and shadows and lights and all sorts of beautiful effects. Then you can split, rather than using one single server to do an Unreal scene, you can split the Unreal scene onto multiple servers and either split it per object, sort of like per layer, if you will, or you can split it as like different servers handle different tiles. So it's a very powerful way of not compromising the frame rate of the 3D content you want to display, where your avatar gets rendered in, and also not compromising on the real-time system speed of the motion capture system.
Can you go back there for a moment? I have a quick question about like what kind of hardware are we talking here? There's got to be some really beefy stuff, right? Like what can you talk about that a bit?
A little bit. Yeah, so these are I mentioned our company does hardware and software. So I talked mostly about the designer software, but we also have the VX servers, which are pretty beefy machines, and part of their secret sauce is cards we call VFC cards, and you can stack multiple of these in one server, and you can output, let's say, 4K from one card. Excuse me. Sorry, the flu there from the toddler. And yeah, essentially you can stack 4 of these, for example. So you have 16. You got 4K outputs from one server, and you can stack multiple servers, so you can see how easily this scales to doing like dozens and hundreds of outputs within a network. And the other types of machines, probably this is where your question was more aiming at, Phil, is what's the secret sauce with these ones? And all I can say is the graphics card is really, really beefy. So we're talking like 48 gigabytes GPU type of affair.
Okay.
So yeah, they handle the work beautifully.
Well,
yeah, this probably would not run on my laptop.
When you say 2 people you can track, I'm guessing that it would be very difficult to track when, let's say, a dance sequence, right, where the people are touching, or how does it handle that?
Yeah, I wish I had the footage, but we actually tested that, so it handles it pretty well. I think we it might be like to share for another time, where there are actors doing frog leaping, and we tested that, and it works in real time. But it's just because the people at Movea have been doing such a great job of not only gathering, like training their systems, but putting it through its paces as well. So not just getting enough data to train the networks to handle all this like special cases, but then try it live and then tweak and kind of work out the secret sauce, like the right balance between how precise does it need to be versus how realistic and how fast can it still remain.
Right.
Yeah.
Interesting.
So these are some simple use cases where you can, in a typical scenario where either if you have like a green screen or if you have the LED stage, you'll notice that people don't tend to have shadows, but you can use like the simplest thing you can do is use the motion capture system to render an avatar that has a shadow. So in this case, the avatar is following, but you're only rendering the shadow. That's the simplest thing we can think of. This is a work in progress demo, so you can see here we have a portal type of effect. So the way that works in our virtual production system, we have 3 different layers, if you will. There's the background that you see on the LED stage behind. There's the actual actor, that's me on stage. And there's a front plate as well. What we call the front plate is essentially like the augmented layer, which gets rendered on top. So when I pass through the portal, essentially the virtual content gets rendered. So this is essentially the result of the full pipeline. So this would be the outcome that would be rendered for the cameras that are going into broadcast. And then obviously this demo also showcased some interactions. So as I move towards the car, I can toggle the particle systems on and off. And when I go towards the pilot section, that triggers a change and the card gets swapped over. So just showing some basic like buttons, triggers, particle system interactions, and so on.
Wow, nice.
Yeah, so
this
fast.
is another. Yeah, thank you. This is another demo from our talented team, Disguise Labs New Zealand. And you can notice how the different objects can, like by stepping on that plinth, it triggers this orbs to be rendered and also following the character, and then a hand gesture allows them to essentially go away. This is a nice, neat self-contained demo. This is actually a demo that was never planned. Like we didn't like plan for this to happen, but this is Max, and she's in our support team. She does awesome work with our software and with Unreal. And like in a matter of days, she just like put up an Unreal scene to recreate the movie Big type of effect with a piano. And of course, because it's Unreal, we can do all sorts of fun things with particle systems.
Man, you beat me to the movie reference there. That's impressive.
Yeah, so it's all sorts of fun things. I might have gone a bit too fast. So that's why I have
Speedster up there.
Yeah, I can always go back talk over more slides or anything like that. And yeah, if people are interested in sort of this, you can scan the code. There's like a thing where you can type in your email and learn more and get in touch with the team. Actually, yeah, let's wait for the Q&A. I might have a couple of other little technical slides, but it kind of depends on if people want to see them or not. So yeah,
I think they do, definitely. Somebody was asking if you could actually go back to that video with the guy in the car that was showing off the sort of lighting, and they only saw the end of it and they want to see it again.
All right, virtual production. Here we go.
Awesome.
Okay.
Yeah, so can you maybe talk through this a little bit more? I think me and Satya were talking over this last time. If you could, yeah.
Yeah, so yeah, what happens here is we have the full VP setup with in-camera virtual effects system. So we get a tracking camera, and it's looking at the scene with the right perspective, and the background looks real, appears real, but it's an LED stage. And because it's an LED stage, we can do things like this, where the content changes like in real time. And on top of that, because it's light, and just bounces around it and does what you expect it to, it reflects beautifully on the cars and on the actor. And the actor can obviously see what's going on and react and interact with the content around him.
Right.
Yeah, and the the nerds out there will notice that this is all one shot. No cuts, baby.
It's very satisfying to watch.
Yeah.
Especially this section towards the end where the scenes flash, and if you pay attention to the actor's face, you notice how lighting just works.
Right.
Very cool. Yeah, Richard in the chat here mentions one of the great things about using the virtual stages like this is that you basically get the correct lighting for free, like as a benefit, which is true. Yeah. Killer demo.
Right. I mean, I mean, people already know probably, but in case of green screening, you have this green cast that appears on the face, and you have to very tediously remove that, either automatically, but sometimes semi-automatically, because the green from the background, it casts over your clothing, it changes the color of your face, etc., in unnatural ways, and that you have to correct for it. And also your face, even after you do that, your face will not reflect the environment, right? Especially cars and things like that, they will not reflect the environment behind them, and this automatically solves that problem.
Yeah, very cool. So yeah, this QR code will where will this take our folks if they scan it there, George?
That should take us to the Disguise website, where they can fill in their details, and they can get in touch and ask us a lot more questions about the Markerless motion capture solution, about Invisible. Speaking of which, maybe I just go through the nerdy slides anyway. So
yeah, somebody already asked on LinkedIn, can we see the nerdy slides, please? So do it.
Of course. So this is a screenshot from like very early days. So the interface is way, way better now. But what I love about this one is not only you can see like the frame rate like 60 FPS for decoding the video frames, but 60 FPS is the output for the mocap data. So it's nice and solid. But what we see here are two 2D skeletons, and the 2D, like the lines connecting the 2D key points. The first set is from the actual detection from like 2D from each camera. However, the other color represents the reprojection, the reprojected 3D points that are projected back onto 2D. So this is super useful. Let's say you've done your calibration and you're not sure exactly how good your calibration is, even though you might look at some like reprojection error numbers or some metrics like that. But you want to get a feel for how good it is as you walk around the scene. Notice if there's any blind spots or any areas where maybe the accuracy isn't as good as you like it, then this will help you debug really, really nicely. Because in a perfect world, what you want to have is an alignment between the two skeletons. So when there's minimal reprojection error, the two will just merge. And in case something goes wrong, then these two will diverge. So in terms of calibration, maybe I should talk a little bit about that. This involves two steps, like two types of calibration. One is called intrinsic calibration. So all our people coming from OpenCV land will be super familiar with this because we have multiple cameras, want to use the pinhole camera model and want to get rid of the lens distortion from each camera. We do traditional chessboard type of calibration. And then the second type of calibration is called extrinsic calibration. That's where we need to figure out the pose, like the pan, tilt, like essentially XYZ position and rotation, like the rotation and translation matrices for each camera. And currently our system actually has two methods. One is by tracking key points and a person moves on stage. And the second one is actually displaying markers on the LED stage, since we have one already. And that's much faster, but there are cases where one is better over the other. So hopefully this covers, yeah.
When is this thing better? When the second case, right, where we are using a human, that's a pretty difficult one, right, for calibration. When is that better?
Well, there's a very, very kind of niche sort of setup, but it really depends on the LED stage sizes. So it really depends on what people end up doing. So this LED stage is a very small one. It's like 2x5 by 2 by 2 meters. It's our development stage. So as developers supporting the QA team get to play with this all the time. But in this case, we're lucky because all these faces, they're orthogonal to each other. So if we display the marker, like let's say like a Cherukho chessboard type of marker onto the floor and then each wall, then that's great. We can mimic somebody actually waving a calibration board physically, and we can get a calibration done. Right. However, if you remember the car scene and how big that LED stage is and the fact that it's curved,
right?
What you don't want is to display that marker board as if it's bent. So you want your calibration board to be straight. So you can get away with it if, let's say, the subdivision level of your curved LED wall is like rough enough that you can still get big enough straight sections to display the marker on. But if for some reason that's not possible, and some people have like custom-made LED panels that are curved to begin with, then in that case, you can still use the person-based calibration system.
Interesting. Okay.
Calibration once again rears its ugly head on this show.
Yeah. So this is just a quick test. I mean, it's kind of fun that we have a feedback loop in the background, but it's just testing. I'm just preempting. People might ask, like, what's the delay like, or what's the latency like? Because we do get like 60 frames a second, but there's multiple cameras, and it goes through this whole system, this whole pipeline to get the data back. So in this case, I'm disabling some filters. And notice the last clap might be a little jittery on the skeleton as opposed to the first one, ever so slightly.
Yeah.
But yeah, this pretty much like highlights. We're looking at maybe like a couple of frames delay at the moment, so like somewhere around like 200 millis.
Yeah.
But that's still early days. We're in closed beta at the moment, and obviously that's one of the main things that we're looking at improving over time. So it's for what it is. I'm pretty happy with it. But obviously, we'll have people that will always want more.
Yeah, very impressive stuff.
And just to give you an idea, like testing stuff. So this is the same F1 sim that is just me goofing around testing after doing an extrinsic calibration. Like, okay, how does it feel like? Does it handle things? Like, how well does it work? So yeah, the frame rate's like nice and consistent, and the 3D avatar is displayed like pretty solidly. Like there's not a lot of jitter. Like it's nice and smooth. So very happy with these results. Yeah, hopefully that answered some of the questions. But if people have more questions in the QA, I'm more than happy to answer.
Yeah, we'll go ahead and do our giveaway first here in a moment. Got some good questions here from the Peanut Gallery. Yeah, go ahead and unshare your screen there if you will, George. Yeah, so that was awesome. Thanks so much for joining us this morning, George. Really interesting presentation with some cutting edge mocap and projection. And as I said during the show, I think large scale maybe undersells when you're projecting on the Burj. Like it's maybe a little bit bigger than large. So in case you need a reminder or this is your first time joining us, one of the things we do on this show is a giveaway to you in the audience. I am going to ask a trivia question based on today's presentation, and you in the Zoom chat will have the opportunity to win the OpenCV course of your choosing, including the new Mastering AI Art Generation course, which was just successfully funded on Kickstarter and Indiegogo. The way this works is I'm going to ask a question, you're going to answer in the chat. The first person to answer correctly gets that course. You can see what courses are available by going to opencv.org/courses and choosing your course there. If you win, even if you don't win, you can go there and spend a couple $100 and level up your skills, invest in yourself, invest in your education. It always helps to upskill in times like this when we've got this economic downturn with tech and everything. Learn a new skill, make yourself more marketable. So if you've won in the last 2 months, please do not answer and give somebody else a chance to answer. I have a feeling that you all probably clocked me on this one and it's going to be a record. It's going to be record time. All right, get ready to answer.
Like 5 answers ready.
I know they're just. You got to try to throw them a curveball, or rather, more hopefully a knuckleball. But so earlier we saw this really awesome projection mapped room with the stars, and people were walking around in it. There was 60 terabytes of data. How many 4K outputs were part of that scene? Oh, you're close, Toto. Close, Toto. We got one. All right, Jeff Challoner was our answer. Is our trivia winner for this week. The answer was 46. The answer we were looking for was 46. Congratulations, Jeff. Please send one email to phil@opencv.org with the course you would like, which once again you can find by going to opencv.org/courses. Let the team know which course you would want. That, of course, covers only any individual course, none of the bundles. But congrats. Right. We've got a bunch of questions here from folks. Let's see. So Angela says, great presentation. Do you have any recommendations for types of cameras to be used with this object detection, motion tracking for computer vision that work well in, say, darker environments or environments that have wide ranges of the available light, George?
Right. Yeah, that's a tricky question. So obviously, everyone working in computer vision knows that cameras and lenses and lights are at the core of it. Like beyond any algorithm that can save you. Like if your setup is good, if you get good data in, then you can do some work. So it's quite a packed question because there's a lot of things going on. First is low light environments. Second is environments where the lighting changes a lot. And then if you're looking at object tracking and people tracking and so on, that there might be something specific there. So for example, if object tracking depends on the object, if it's something simple, let's say like a ball or a sphere, it happens to reflect light or something, maybe you can get away with more. But obviously, if you do people tracking and have accurate motion capture with not a lot of jitter, then obviously getting better data coming in, that's great. Unfortunately, I don't think I can recommend specific camera models. Obviously, kind of depends on the situation, but maybe some ideas that were some areas you can look into. So In terms of low lighting, obviously there are infrared cameras, and you can flood the scene with infrared lighting. So in the previous slides, I mentioned the camera tracking system. A lot of these use a system called star mapping, where essentially you mark either the ceiling or the floor with a couple like shiny objects, and then the cameras use the scene is flooded with infrared, and they're infrared cameras. So as it moves around, it's got a really, really clear idea of where every single marker for the camera tracking system is. So this, just to clarify, this is the in-camera visual effects type of camera tracking, one object, not the same as the markerless mocap for people. So you can mimic a similar type of scenario. Obviously in the dark, you can use other systems. So I think OpenCV had a bunch of competitions, and they introduced this OpenCV AI cameras by Luxonis, and some of them have active infrared projector built in, which also helps.
The new ones have,
Yeah, OpenCV
So,
Pro.
Yeah, that's the one. So those could be good as well. The caveat there, because obviously I wouldn't have enough information of, how large is the stage that you want to track and all of these details, you would need to pay attention to, the specifics of the lens, like what's the horizontal, vertical field of view, what type of lenses, if it supports other type of lenses, what do you need to essentially not just see, just get a good view of the whole scene, essentially. Yeah. So I think in terms of that, even like, the older Kinect and things like that use similar sort of techniques with flooding the scene with infrared or like with a known pattern and then getting more information in the dark. If you do use an RGB camera and you have this second scenario with fast changing lights, that'll always throw things. So if you just rely on an RGB camera, and then there's settings on the camera as well, like if you want to leave some like auto white balance or auto gain or all sorts of like automatic options, whenever you have flashing lights or something like that, it will trip up your camera, that's for sure. So you can like take that into account, I guess, and like knowing what type of settings are coming up, you can at least mitigate that to a certain degree. So let's think of, you have like a machine vision camera SDK that allows you to programmatically trigger these. And if you know what sort of lighting comes up in your scene, then you switch between your camera presets to try and handle that best you can. So hopefully that answers your question.
Yeah, I think so. Anything to add to that, Satya?
No, I think that's a pretty comprehensive answer.
Yeah. Eric would like to know, for finding the skeleton pose here, is this a custom built model or are you using something off the shelf? Did you prototype using any, say like, OpenPose, Darknet, these sorts of things, or is it all kind of secret sauce?
Right. Yeah. So again, loaded question, and you already sort of half answered the question with the secret sauce, but I'll try to explain as much as I can. I mean, it might end up that this answer is more like a pitch for two more talks. One is omnical and multi-view geometry, like that can be a talk on its own, and maybe the people, lovely, and maybe the lovely people at Movei want to give a talk about the same system, but a lot more focusing on this type of questions, obviously without giving away too much of the secret sauce. All I can say is it's not just one model, it is a series of models as far as I understand. And my understanding, again, is limited. Like people at Movei would be way better prepared to answer this accurately. And they train this in-house with their own data sets, and they iterate pretty fast on their models. So we had a difference where at some point we had a performance hit when we're doing two people tracking, switching between one person and two people would go from like 60 to like 20 FPS, and it was quite a challenge for them, but they handled it super nice. And in a matter of weeks, they just came back with like a different model and sort of like different setup, and like, hey, 60 FPS all around now. And we tested like with 8 cameras at the same time. So again, like Dr. Satya might know about this, once you start adding more cameras, there's more time to compute from every single camera, and then handle all the data from each camera to merge it into one cohesive 3D coordinate system. So it's very nice to basically see them handle that. So hopefully I've answered this one.
Yeah, so these systems, one of the problem with off the shelf is that, at some point, let's say if you use MediaPipe for this thing, right? You can prototype using that, but you will soon realize that it's not enough, right? You cannot, you will need very soon, in a few months, you will realize that you need some feature that they don't have, or it doesn't perform on certain poses, right? Let's say in the kinds of poses that you were showing, I'm pretty certain that Google did not train on those kinds of difficult poses, like some dance poses, ice skating poses, etc. It could be very challenging for it to do the right thing, right? And in that case, you have to train your own model, right? So it's a good, if you're a startup, you're just starting out, it's good to use open source models as much as possible. But you will soon realize that you will have to train your own. In fact, OpenCV.ai, we have a new product called Copycat.ai, which produces augmentation for data.
Copycat.co.
That's right. I keep messing up the name. Sorry.
It's all good. I got you, dog.
So we produce, for the same segmentation, you can produce new poses for the same person, so it's pretty good for data augmentation, and these things are going to get much better over time. I'm assuming with these new data augmentation strategies and other things. It's mind-boggling how things keep getting better and better when you think that, oh, how else can it get better? Now we have this new data augmentation strategy that can just take it to the next level.
Yeah. So just to add to that,
go ahead, George.
Ages ago, I took one of Dr. Satya's courses, and I tried like a really, really ambitious project, which was trying to do kind of like a motion capture system for puppets. And I ended up going with IMUs given like limited time. And at that time, I think OpenPose just got released. I think that was 2017, 2018. And I was so happy just to try it and give it a go. And with a pretty decent GPU, I barely, and lowest resolution, barely managed to get it like 3 to like 7 FPS. And it's like, no way I was going to get that to work. So it's nice that the architectures on these models keep changing as well. So it's good to kind of keep up and look at the open source ones, but look at how they change. Speaking of courses, there's what is it? It's the Introduction to PyTorch course actually that covers dense pose towards the end of the course.
Yeah.
And that's really, if you want to get started into something similar to this, that I recommend that course a lot. It's very nice.
Thank you so much. I actually I had a follow-up question on that. When you took this course, which year, just for the audience, which year did you take our courses, and what was your stage at that time? Were you a beginner? What stage were you in? And how did it help you in your journey going forward?
Okay, yeah. So I remember it was the CV for Faces. That's the first course I took.
Right.
And I think that was, I can't remember if it's 2017 or 2018, but definitely somewhere around it.
Yeah.
Yeah, thank you. Yeah, and the course has been great. As opposed to other ones, it's like very hands-on, and you do need to do your homework, and you do get loads of feedback from the forums, and like super nice, as opposed to just having a playlist of videos on YouTube, but then nothing much coming out of it, if you know what I mean. So it's very nice to kind of get involved with the community and get all this support. And yeah, I was coming more from like a hobbyist level. So my background is actually more like a creative tech type of field rather than being like a software engineer trained from the go. I just transitioned from like fine arts and graphic design into coding. So some of these things obviously I found very intimidating. So it's very nice to have something that kind of breaks things down, that things that appear complex, like, let's say convolution. It's like, imagine how fun it is to make your own Photoshop filter whenever you want. It's as simple as that. Okay. And then use the same knowledge to go from something as simple as a filter to, let's say, detect edges or blur something, to go on to machine learning and to use the exact same concepts for a convolutional neural network. So yeah, I found it very, very helpful. And obviously, I do more computer vision now than I did before. So obviously it helps the career.
So what was your role like a technical artist before? Am I okay?
Yeah. Yeah.
You are legitimately working in computer vision and AI, right? So yeah, I keep asking, one of these questions that I ask people, it is a little bit blunt, but it helps a lot of people who are looking into AI. I think, right, based on all the feedback I'm getting from students, that if you are in AI, let's say you're a Python developer, right, and you switch to AI, you can easily have an increase of, from about 30 to 50% increase in your income or your salary. Is that a fair statement? This is based on what I have seen with other students.
I mean, yeah, it's the main difference from, doing different types of work. So yeah, I mean, I don't know exactly how to answer, but definitely going from like just doing purely creative things to being able to deliver small pieces of software here and there and prototypes and things that help this sort of technology is obviously needed and rewarded.
Right, right. So
Definitely helps me get paid more, that's for sure.
that's true. No, it's people think that, okay, there is this wave of AI, right? And like on an average, if you search Google, you'll see that an average AI engineer makes about 120K per year, right? As an entry-level engineer, which is just mind-boggling to me, right? Even now, I'm surprised. I know the market, but I'm still surprised by that number because people who are trained as software engineers alone, right? They would make, as an entry-level position, you would make 70, 80K in the United States, right? And in good places.
Yeah, I mean, it took me like 10 years to hit that number, like,
right.
Yeah.
Yeah, so it's a booming industry, and I feel that careers would be transformed if people are on the fence. It takes a few months. It's not like, oh, you just take a course and that's enough. No, you have to take a couple of courses, right? And then work towards it. You have to do all the work needed, but there is a path to go from a software job to an AI job in a relatively short period of time, right? In a few months. Which is available. So I mean, you're one example. There are a few other examples who people have done spectacularly after taking our courses. So I'm so happy whenever I talk to people like yourself.
Yeah, and the kind of the last note similar to the same topic is that you could look at like this sort of big numbers and they're easier to hit if you go to something like finance, maybe trading, this sort of thing, if you're into that. But like, there's nothing wrong with it. Some people actually really, really enjoy it,
right.
And there's loads of like high performance computing that's necessary there.
Right.
But personally, I'm more motivated by doing something with people, for people, creatively. So when you tie in the technology of like tracking like hands and faces and bodies and all this sort of stuff to power live shows and movies and all this stuff, I find that a lot more rewarding. So my advice is, for people that aren't sure, as long as you make it fun for yourself, then you're definitely going to have the drive to kind of learn more and do more. So it's less about learning nerdy matrices and what can we do with like NumPy and PyTorch, and more like what's the end product, what's the end result, what can you ship with this. And maybe you want to work for someone, or maybe you can make your own solution and make your own product.
That's right.
Yeah, there's definitely a lot of opportunity out there. Anytime there's a new emergent tech, anytime there's a lot of upheaval in the economy, that is the time when opportunity is greatest for stuff like this. It's when things are on the downslope, and on the upslope, that's when you have the most chance to make a big impact in your own life and in the industry. So don't despair out there if you're among the laid off recently. Good times are still ahead for you, I promise. Satya, we got an awesome show next week. We're going to Embedded Vision Summit. Do you want to talk a little bit about that with the folks here? It's May 22nd through 24th. OpenCV will have a booth there. It'll be booth 1008, and we'll have stickers, we'll have buttons, we'll have a little something extra, a little fun thing for you to try out at the show as well. Any thoughts about the Embedded Vision Summit, Satya?
Well, my main thought is, first of all, it's a very good conference for people who are interested in edge AI and all the embedded vision stuff. You will find, people from all different companies. They congregate there, and it's spectacular. I really like that conference. I've been going to that conference pretty much every year for the last few years. So it's a good conference. And the other thing is that I really want to meet people. So if you can show up, if you are at that conference, I would love to talk to you. If nothing, it doesn't need to be technical. I just want to talk to people who are in the OpenCV community. So I would love to catch up there, show us by our booth, and we can have a chat. We'll also showcase a few things like Copycat. I'll show some examples there. We will show OpenCV face recognition, and this is there are various products in OpenCV face recognition that it's difficult to explain, but once you see it, it's very easy. So we will showcase that as well. And, Gary will also show up. So you can, Gary Bradsky, who's the founder of OpenCV.
Yeah, the rare and elusive cryptid, Gary Bradsky, will be making an appearance in public, a rare public appearance. So yeah, you don't want to miss that one, folks. Well, like I said, we'll also have stickers and pins. Feel free to drop by and pick up one of those. We'll be showing off, a little bit of CVAT, all of the different OpenCV catalog of products at our booth 1008. Yeah, I guess that's about it. Any last thoughts before we send everybody home, Satya?
Yeah, one other thing about Embedded Vision Summit, I just realized that last year, a couple of years back, I had bought a bunch of OpenCV AI kits, which I thought that I'll gift it to my friends, but I didn't find. I gifted a few to my friends, and I did not find worthy enough friends for that.
Wow, man! I hope none of your friends are watching now. You might have a few fewer friends.
So I'm going to give those away at the Embedded Vision. People who visit, we'll just do a raffle or something. And
yeah, that's great. We're speaking of giveaways, you will also have the chance to win an Oak D Pro W. That's a $450 value if you stop by the booth and check out what we've got going on over there. So yeah, George, thanks so much for joining us today. Awesome presentation. I think you're right. Maybe we'll have to have the folks from Move over here to talk a little bit more in depth about, I feel like we could do 4 more shows about the technology behind this extremely impressive live real-time markerless motion tracking. It's super cool. Thanks a lot, George.
Thank you so much. It's been a pleasure.
Thank you.
Thanks everyone for joining.
We will see you next week, same bat time, same bat channel, 9 a.m. Thursday Pacific time. I am your co-host with the co-most. Rest in peace, superstar. Take care of yourselves out there. Take care of somebody else if you can, and have a great day wherever you may be. Thanks so much for watching this episode of the webinar. Please hit that like button, subscribe, and don't forget to tap the little bell icon to be notified when new episodes drop. This week's episode was brought to you by OpenCV Courses. Learn computer vision and AI from the best at opencv.org/courses. If you'd like to be in the audience next week, subscribe to the OpenCV newsletter.